Okay, right, ladies and gentlemen, I want us to look at solid grade 12 solids geometry. I want us to look at this one that is there by page 68. So these are the given views with their projection symbol. So which means this is a front view, this is a top view. So there is the question there. They're saying given the front view and the top view of a right rectangular hexagonal prisms with a right square hole and a right rectangular pentagon pyramid. Specifications, so you can go through them. The instruction, they're saying we are supposed to draw this using a scale 1:1. So we are expected to draw the given front view and the sectional top view and the sectional left view, show all the hidden details required there. So the very first thing, we are going to draw the given view. So we are going to draw the given view. Let's start with the top view. So using a scale 1:1. If you check it there, we are having across the flat hexagon and with the diagonal square, if I may call it like that, and the pentagon. So you must know the procedure of how do you draw all such kind of shape. So we know what this angle ne? It's angle 45, you understand? So we can start. I'll start drawing that diagonal square. Maybe somewhere here out of dimension. I'll start to draw a faint line, and like this. Now they said this square is what is 29 millimeter, isn't it? 29 millimeter from here till here, 29 millimeter. So we know the properties of the square, all the sides, they must be equal. 29 millimeter. So you can have your drawing canvas, then you open it to 29. There is your 30. 29 is right there, isn't it? From here till there is 29 millimeter. So I come there, I mark and mark there. So now I can draw it solid from here till there. This what is 29 millimeter. So this one I don't need it anymore. So now there I can put a vertical center line now. Long, short, long, short. That's how you draw a center line, isn't it? So from there I can put a horizontal center line. So now have this one in place. There you go. Then there you go. So that's a diagonal square. Then from there, what can I do? I can now draw the across the flat hexagon. So the dimension of the hexagon, with the properties of the hexagon, all the sides, they must be equal, we understand, and it's across the flat. And the set is 32. So I will take my drawing canvas, open it to 30. There's my 32. So now I come at the center of my set of my faint line. I draw a faint line. Then from there I come up on the vertical center line. I come and place my compass there, further extended to the center, isn't it? Is the radius. Then I give it a mark there and strike an arc there, and I come on the bottom one. I do the same thing, strike an arc there, strike an arc there. Then from there, here we go, there we go. Then after that one, like this we go, and like this we go. We are still drawing the given view. There we go. like this we go. So we've gotten what the top view of the shape of the hexagon across the flat. So right bottom, left bottom, we are having what the shape of a pentagon attached. Is attached, it isn't it? It's of the very same dimension, you understand? So we are told ukuthi it's of the very same dimension, you understand? And you know the properties of a pentagon. All the sides, they must be 32 millimeter with 5 corners, you understand? Then from there, take your drawing canvas, open it to the very same diameter 32. Open it to 32. Come and place your compass here at this bottom part of your across the flat hexagon, and have a faint cycle like this, and come and place it here again, further extend till there, have another one that's going to behave like this. Then from there you see that we've got this one and this one and that one. They're of the very same same radius of radius of 32. You see, what is important there is this gap of yours, Then from there, take your 30 millimeter ruler, join this point and that one, where these two cycles, they're crossing each other. It's your point, this one and that one, you understand? So have this line, and if you take a closer look, this line is also passing our center of the across the flat square, the center of the hexagon, you understand? So having joined that, so we are having that point. That point is very much important. That point, it is very much important. So now we are going to take this point and join it with this one, but we are going to further extend your line a little bit down. There you go, you understand? So now if I place my compass from here till there, further extend till there, you'll find that it will be exactly at that point, which means if from here till there is what they said is 32. So the moment you place your compass from here till there, you'll find that it will be exactly at that point. Let's prove it. Which is the same as, you know, the sides, they must be all equal most. So there you go, which is this one, which is that one, A1. So which means now without fear or favor, we can construct this one solid. You know why are we using this method? Because our pentagon is not a horizontal flat there. There is a certain degrees, maybe it can be 5 degrees anti-clockwise, you understand? So now what we are going to do, we are going to project this point again to that one, but further extend it up until it touch there. So let's do it, this point to that one, where this cycle and this one, they are by crossing each other, you understand? So there you go. There you go. Once it touches there, then we can stop. Let's prove it. Uguti, is this side equal to this one? Place your compass here, further extend it to this point. Yes, indeed, it's absolutely there. Then from there, this one, we have it. A1. So now you can tell Uguti, we're supposed to go like this and like this. So to get that, now come and place your compass at this point. From here, then you strike an arc there. Then now we can have this one dark. After you've drew it dark, come and place your compass here, further extend it to that point. So if we are correct, the moment we place it like this and we come and bisect it like this, You see that is absolutely coming there. So that's how we've gotten our pentagon. But then you see that this pentagon, there is a center. There is a center line of it. So now to get that center, we are going to see to take this point from here till the center, from here till there, which means this line is the center of this one. We must get it right there, and we must get it right here as well. So how? Come and place your compass here till there, then come and give it a mark here. You understand? After I drew like that, so you are going to take this point directed to this one. You understand? So that's going to give you the center. So now where this one and this one, they are bisecting each other, that's going to be a center. There it is, your center. You understand? So now we can project, we can draw this one faint. There it goes. Why are we saying faint? What is there by our given view is not faint, it's dark, because there is a cutted, it's cutted up there. You understand? It's cutted. And if you look at the cutting plane, it's actually starting exactly at the corner there, exactly there by the corner. You understand? It's not starting somewhere there. It's not starting somewhere there, but it's starting right from the corner. You understand? So we can have it, this one solid for now. I mean, not solid, but a faint line, not that much dark. You understand? There you go. Like this we can go, like this we can go. So it's not dark as compared to the outer ones. You understand? So let me give them their names. So I can say maybe this can be 0, this is 1, this is 2, 3, 4, 5, 6, 7, and 8. You understand? So yeah, I can say maybe this is A, B, C, D. You understand? So that one I can call it maybe A and K, point K. So now let's go up with our what? With our front view now. We can now say the top view is complete. We've drew our top view complete. Now let's approach the front view. So from here going up, I'm going to record 20 millimeter. We always space our 20 millimeter. That's orthographic projection. So from there, get a horizontal constructional line, which means faint. Then after that one, erase this one before it confuses you. So I'm going to project this line, faint, there it goes, all of these points. And this one, if you check very well, it's in hidden. So hidden line, going down like this, there it goes, which means further extend this center line up there, and this one is hidden as well. And this one as well, there it goes. This one faint. This one I can stop right there. Even this one, action. Let me stop there because they will be going to your apex point. Understand? This one is the what? Is the line of your pentagon, and this one, so I can stop there because they'll be going to apex point. You understand? So this one and 0.8, stop down there, 0.0, stop down there. So from here till there, I'll construct it solid without fear or favor. Then now we can go up with what? With the height of, where is it? With the height of 72 millimeter. 72, 71, 72 is right there. Then I give it a mark right up there. You understand? So here is it. Then from there, what is happening? What is happening? The set is there is the cutting plane. The cutting plane is at an angle of 45 degrees, and it's actually starting right from the corner there. You understand? It's not passing somewhere there. It's actually right from the corner at an angle of 45 degrees. And even if you don't have this, having these lines, because we are told Uguti is passing through that center line of yours. Let's say you do not have that set square of 45 degrees, but I don't know at the end what are you going to use to section, because we section using 45 degrees. So there we go. There we go, like this. So whatever that is beyond the cutting plane, I am going to draw it as hidden, because now it's no longer there. You understand? Because whatever that is beyond the cutting plane, we are going to consider it as an off cut. And if you see the apex of your pentagon, the apex point up there is which one? I can have it straight up there. It is. So I am going to construct this point till up there. There you go. As well as this one from here till there, but from after the cutting plane. So which is this one, the second one is this one. Yes, take it up, but then I am saying it's now cutted already. There it is. So which one is this one? Is that one of a hexagon? So it's going to be in hidden. This one, but as from, it's also hidden there. From here till the dark, but hidden details, short, dash. Okay, so yeah, without fear or favor, have it solid. There you go, solid. Right, then we are supposed to expose now the cutting plane now. That what is it cutted? The moment they were cutting it, what was affected, what was not affected. You understand? So we are going to section where the hexo cutted. So let's start with the what? With the pentagon. So this point 0 there it is. You understand? So this one there, I can say this is my point 0. You understand? So there it is. This is my point 8. Then this one is going to be 8. This one is going to be my point. This is 8. This one is the apex up there, which is point K. We said it's going to be point K, right? And then this one is 0.7. My 0.7 is down there. And then 0.6 is right here. We are still busy with our what? With our pentagon. Let's see. Let's just consider as if this diagonal square with the across across the flat hexagon is not there. So now we've got this line, this one from here to apex point, isn't it? So now 0.8 there, it goes from here to apex point. Once it touches the cutting plane, you are going to construct it vertically down. So there you go. So I've got a point there. I've got a point there. Then from here, this one, which is isn't this was 0.8, we are going to go to 0.7. There is no any other point there. There it goes from here to apex point. Once it touches the cutting plane, it's going to go vertically down. Construct it. There you go. So which means I've got a point there. And this point is also affecting what point? This line of point 0.6, which means there it is. You understand? So I've got a point there, I've got a point there, I've got a point there. You understand? So now to get this point 1, because this is 0, this is 1. And there is another point that we just missed, which is point what? Point 0 being affected with what? With the same line. There it is. Oh yes, remember your cutting plane. Your cutting plane is actually starting right there. So we cannot have a point there. So this point of 0 is actually right there. Let me even construct it before it confuses. There you go. There you go. And like this we go. Why am I starting right from there? Because this cutting plane is starting right from there. If it was starting somewhere there, we're going to take this point down and have a point somewhere there. You understand? So there it is. Then after that one, I am going to have this a point. Let me see, there it goes. This one. So we have to take this 0.6, which is this one. There it is, which is this point. Because this is 0.6, this is 0.7 up there, this is 0.8 up here, this is 0.0. You understand? So the 0.6, take it, don't forget it. There you go, which means this point actually is not here, but is somewhere there. So that is why you have to be careful. It's somewhere there at the line of 6. Remember, it's which one? It's this one, isn't it? This is 0.6 there. It goes from here, goes to your what? To your apex point, which means once it touches the cutting plane, becomes vertically down. It's going to meet up with what? With 0.6, which means it's right there. Because now I was confused. Why are they in the what? In the same line. Understand? So now construct it. You understand? So now the point 1 now. So how do we get point 1? Because this is 0, 8, 7, 6. We've got supposed to get point 1 somewhere there. So this is the point 1. You must take it up. Once it touches there, you take it to your apex point, which is right there. So this is the point 1 we're supposed to take. There is point 1. This is the point 1, very close. So you must know your step actually. So from there, you project it down to your top view. So there it is. Once it touch that line of yours, so now you can have it. There we go. Then back to point 0. You understand? So this, since this is solid, it's not a hole. If it was a hole, we're going to leave it like this. Since it's solid, we have to section now. So section using 45 degrees. There we go. There we go. So your hatches, they must be at an angle of 45 equally spaced. 45 degrees equally spaced. There you go. There you go. So that's how your pentagon is going to be in sectioned. And then let's see now what is happening in our hexagon. So this hexagon is starting from here to there, and this line I suppose supposed to be dark. Yes, from here till there supposed to be dark, and even right from the given view is solid there. So from here till there, without fear or favor, supposed to be solid. So now our hexo started to cut from here going down. So from here till there is not cutted. So which means I am going to have this line solid from here till there. From here till there. So now from here going down is going to be in section. So I have to section it. Section, there you go. Like this we go. Like this we go. So that diagonal square, it is going to be a hole. So you are not supposed to put your hatches there. And oh no, we don't even section here. What am I thinking? Because the hexo started to cut from here, which means from this side you don't have to section. So erase your hatches, this one and this one. But from here till here, it's okay. From here till here, erase it, erase it. Yes. There you go. There we go. They must be equally spaced. There you go. There you go. Sectional drawing. Right. So we are done with our top view as well as our front view. So let's see the question was like like they were like draw the given front view, the sectional top view, which is what we've just finished, and a sectional left view showing all the hidden details. So now we are going to use the orthographic projection method of what? Of having a line that is at an angle of 45. And remember the set in what? In first angle orthographic projection. So which means if we follow the protocol of orthographic projection, if we have a front here, below it there is a top, which means right away from your front there is what? There is left view. So you are going to have this line solid like this, right from the bottom right hand of your front view. So take this 0.3 and 0.4 supposed to be in line with what? With 0.2. Once it touches this line of yours that is at an angle of 45, you can stop this center line as well as this one. There you go. 0.1 in line with 0.4, 0.6 of your hexagon, also even existing there by your pentagon. 0.1 is existing there by your pentagon as well. So 0.0, there you go. 0.7 on its own, 0.8 on its own. So you can easily tell Uguti, this pentagon of ours is not a straight one. There is a certain like an angle there. So from there Once they touch this line, project them vertically up. There it goes. There it goes. And the center. There it goes. Then just extend this one just a little bit. You understand? Then from there, these ones, they must, actually these ones, once they stop here, it's not necessary for me to take them further up, because there is an apex point up there. So I'll stop like 0.6. I can stop here. Not necessary for me to go up, because from here it is supposed to go like this, né? Like this and like this. Then this one as well. Stop there. Stop right there. Stop right there. So now I must come and take the point K, which is our apex point. It's this one. From there, go up, which is, we said is point K, which is my apex point, right? Then from there, what can we do? Take this one to point K. Faint. There you go. And like this we go. This one's already there. This is 0.0. There you go. And like this we go. Okay, now these points from your top view, when they go up, once they touch the cutting plane there by your front view, they must be constructed going horizontally towards your left view. So let's take let's take them one by one, point by point, point by point. So I've got a 0.0 there. We are tracing the ones that are at the cutting plane at the moment. So let's take 0.0 there. It goes from here. Must intersect with this 0 of this side, isn't it? So there it goes. I've got a point right there. So we are starting with the what? With the pentagon. So we've got 0.0. So let's give them names, these ones. I'm going to say maybe there by 0.0, I've got a small letter A, B, C, D, and E. So in small letters now. Why? Because our diagonal square, it has got alphabet points in capital letters. So this point A, if I can name it as well up there, this small letter A, you understand? So there it goes. I've got small letter A there. Small letter A. So let's take small letter B. You are going to construct it. There you go. Once it gets here, there you go. Once it touch here, to point K, which is your apex point. Even this one, remember, which one is this one? It's 0.1. There it goes, isn't it? Supposed to take it right there. Okay, capital letter A, there it goes, which means is this capital small letter B. How did I got it? Is this one, isn't it? From here to apex point, which means take it to your left view. Remember, this is small letter A, small letter B. This is the line of small letter B. From there, you understand? Goes, so which means I can even name them here so that they don't confuse me, small letter A and small letter B. You understand? So from there it goes. So it's supposed to give me a point with which one? With there it goes, there it goes, there it goes. I've got a point right there, which is small letter B. Then from there, just follow the protocol. Let's go to point C now. In our top view, construct it. There it goes. Once it gets there, go up. Then from there it's going to point K, which is the apex point. There it goes. So this small letter E is which one? Is this one, isn't it? Which is 0.6. Small letter E, 0.6 now. Take it horizontally. So small letter E, which is this one, right next to A, isn't it? So there it goes. I've got a point right there, which is small letter E. Then after E, I've got a D right from your top view. So there it goes. Once it touch there, go up. This is point E. From there to your apex point. There you go. So come and trace it. See, this is D, not E. Because this was C, A, B, C, not E. Sorry for that. Which is this one. Then now we're looking for point D. It's this one. There it goes. There it goes to apex. So D is what is right there. It's this one. So this is the point. You take it horizontally. So is this one. There it goes. There it goes. Giving me a point right there. This is C. This is D. That's when we can talk about point E. You see, that's how we construct them. We don't just construct points, then once after that one, because if there are many, they might end up confusing you. Take them one by one, plot one by one, plot one by one, you plot. Then once you get there, apex point, which is now point E. I was in a hurry to meet point E. This is point E. If you construct it up, there it goes from your cutting plane. Point E there. It's this one. So there it goes, which means it's right there. So now we can have it constructed. Construct it. There you go. There you go. Like this we go. There you go. And there we go. So that's how we are going to get that shape of your pentagon cut it at an angle of 45 degrees anti-clockwise direction. You understand? So now let's see how are we going to have this one. Okay, the left of across the flat hexagon. So let's see how do we go about it. So there it is. This is 0.3, which is this one, and there it goes. This is 0.2 and in line with 4, isn't it? Then there it goes, there it goes. This is 0.1 in line with 5. There it goes, there it goes, there it goes. 0.6 is right there. So which means I can still further extend this point. You understand? So there it is. There we have to get our what? Our left cutted hexagon with the whole diagonal. So now there, if we've got this one, this point right there. Okay, let's start right from A, B, C, D, isn't it? So if my A is there, it's going to go like this. There it goes. This A. So which one is this one? Eh? Take it. Let me take it. Yes, it's that one. Then from there it goes to, once it cuts the cutting plane, go to your left hand side. There it goes. There it goes. It's giving me a point right there. A point right there, which means I can say this is capital letter A. How did you got it? There you go. Once it touch there, go up. From here, once it touch the cutting plane, there it goes. It's giving me point A. So point B is this one. There it goes. Once it touch there, take it up. Isn't it? That's point B. There it goes. Once it touch the line of 45 degrees, go up. So what is here? It goes, once it touch the cutting plane, it goes this direction. There it goes. There it goes. There it goes. There it goes. I've got a point B right there. You understand? So C, which is this one, that goes in the same line with what? With A here. So what is here? Which means our point C is right there. Then point D, construct it. There it goes from here, goes up. So point D in line with what? With point B. Eh? So there it goes. There it goes from here. It's this one from here. So which means I've got point D, capital letter D right there. So now I can construct it solid. There you go. There you go. Like this we go. Like this we go. Then from there, remember that your across the flat hexagon was not cutted till down like the way we saw our pentagon being cutted like that. You understand why? Because of, remember, this is point 4 and 5 of your, or across the flat hexagon, isn't it? And then from here till there is this one, from here till, which means there is what is point 3 and 6. Then where is 1 and 2? This is point 1 and 2 of your across the flat hexagon. So where is the cutting plane ended to cut is actually right there by your hidden detail. So this is the same point. You are going to take it, you understand, you are going to take it horizontally towards your left hand side. So what are you going to do with that? So there it goes. So which means I'll use the line of 1 and 2, isn't it, to have it dark. So there it goes. Trace it. 2 in line with 4, isn't it? So I've got a point there, and 1 in line with 5. There it goes. There it goes. From here goes up, which is this one. So from here till here I can have it solid. From here till there I can have it solid. Then from here it's gonna go up towards 2.3, which is this one, isn't it? And 0.3 in line with 6. So there it goes from here. There it goes from here, which means I've got a point here. Let me trace it for you. There it goes, isn't it? From here going up, and then from here, once touch the cutting plane, come this direction. So which means again 6, it should be there, because 3 in line with what? With 0.6. You understand? So now I'll have solid line from here till there, and the solid line from here still right there. And then point, this is point, let me mark them, this is point 2 with 4, then this one is point 1 with 5. You understand? So now I'll get the very same point up there, so that you construct them like this. There you go, like this you go, right? So which means now without fear or favor, I'll have it complete like this: dark here, dark there, dark here, dark till somewhere there. So let's complete it so that we see what is happening with our pentagon, what is left there by our pentagon. This is it. So now let's section. Even here we can now section, you understand? So now if we section, you are going to section like this, 45 degrees. Solid geometry, challenging one. There you go. They must be equally spaced. Yes, that's how your across the flat hexagon cut it at an angle of 45 degrees. That's how it's going to be. So let's section that part of your pentagon. Cut it as well. There you go. Right, without fear or favor, this one is going to be solid till right here. So now this one is going to be dark till there, then have it, then this one, there it goes. So it won't be dark till there, you understand? It won't be dark till up there because it's cut it. So thank you very much, guys. That was solid geometry grade 12. Solid geometry grade 12. So from here, this was the question given, right? This was the question given. This is the solution. Understand? So they said given front view, which is this one, and a sectional top view, which is this one, and a sectional left view, which is this one. So thank you very much for watching. See you on the next video.